All right, welcome back everyone for the fourth session, you know, for term three for the Victorian Selective School exam preparation, maths preparation. And a very good morning to all of you. And thank you very much for sacrificing again your Sunday morning. Now, so far we have understood what an algebraic term, expression, different types of expressions, how you add like terms, how you subtract like terms, multiply, division using two index laws as well. And we also started doing distributive law multiplication last week. So we've gone through a fair bit of a journey here. So far we have touched upon from grade 7 till grade 8 algebra. Today we are going to extend beyond and we are going to go on till grade 9. We'll touch grade 9 algebraic expressions, right, and expansions. Yeah, it's a lot, but then I think you've survived so far, so good on you. Now I will request again, and this time I'll be very strict, that please be kind to the others, right? And not throw anything and everything on the chat unless you are asked to, right? 35 people have joined, a few make a lot of noise here. So please be mindful of the others, right? What I will do is I will pull out uh, the same expansion that we tried doing it last week, which looked like it was tough. So here you go. We want to simplify this one. If someone needed really hard one, that's the one, right? So rather than giving it to you, I will solve it here step by step, and then we will go there. I did not receive any solutions to this in my WhatsApp group. I told you to do that, but if you haven't done that, that's okay. All right, cool. Let's try to understand what this is, right? Now, this I'll change the color maybe. All right. This is a binomial. This is a trinomial. This is a binomial. And this is a monomial. All right. So admin and Shadow the Hedgehog, I mean, please be mindful of the others. Okay. I'm calling your name straight off, right? I don't need any dramas here today. All right, cool. So let's try to expand this first. And we'll do a lot of expansions today. Okay. So A will multiply all this trinomial first. So you'll have A multiplying all this trinomial. I'm using the distributive law. And then positive B will again be getting multiplied across this trinomial. I'm leaving this bit, the second part, as is right of now, as of now. So let's try to do that. Distributive law. I'm just checking if there's anyone on the sitting in the waiting room. Yeah, we've got a few. All right. So A times 2A makes it 2A square. Then A times negative 3A makes it negative 3AB. And then A times positive C makes it a positive AC. Now, B times positive B times 2A makes it a positive 2AB. Then positive B times negative 3B makes it minus 3B square. And then positive B times positive C makes it a positive BC. So I have now expanded this. Now, What are my like terms here? If I just sort of pick up the like terms, I have this negative 3ab and plus 2ab as like terms. So I add them together, and my expansion now becomes the 2a square remains 2a square here, minus 3ab plus 2ab, which is negative 3 plus 2 is negative 1, which means minus ab. We don't write 1 in algebra, right? And everything else is unlike. And I'm just writing it as is. So I have 2a square minus ab plus ac minus 3b square plus bc. That's this part here. I change the color now, and let's pick up this part. So what we are going to now expand is minus 2 within a bracket, a minus 3b c. Now, whether the c stands after the bracket on the right hand side or left hand side doesn't really make a difference. This is as good as saying c sitting in the front, 2ab minus 3ab. And you know why? It is simple because 3 times 2 is equals to 2 times 3. In multiplication, in the world of multiplication, it doesn't really matter how the factors are arranged. So let's do it. So this becomes negative c times negative c times positive 2a makes it a negative 2ac, and then negative c times negative 3b. So this negative and this negative will make it positive, plus 3bc. And now what I'm going to do is I'm going to combine this and this together. That's about it. So I'll change the color again. Let's take blue, or maybe take black or red back, right? Okay. So negative 2a square minus ab plus ac minus 3ab square plus bc minus 2ac plus 3bc. Now, what are my like terms? Are there any like terms? So there's no negative here, my bad. 2a square, there is no like term. Then AB, do I have another AB? No. So minus AB remains as is. AC, do I have another AC here? Yes, I've got negative 2AC plus AC makes it negative AC. B square, negative 3B square. We haven't got any B squares here. So negative 3B square stays as is. And then BC, do you have another BC? Yes, you've got another BC here. And that makes it as plus 5, 4bc. That is the final answer. It is nothing that you didn't know. It is just that they're testing your patience here and your skills. I hope this made sense, right? So you need to get used to it if you want to crack any exam starting grade 7, be it selective school or your school exams, right? Once you reach higher grades, this is important. No, Divesh, we are not doing any quiz right now. Probably I'll throw a question later in the session, right? No quiz right now. Oh, good. Let's move forward. I'm now going to another page number 2 of the whiteboard. So please move accordingly. Now, I'm going to give you a question which I need an answer as soon as you can. So x plus 8, x minus 8. It's a binomial multiplication, a binomial times binomial. Can I have the answer, please? Good. Shiv, it's not y64. All right, let's just do it the way we did the last question. So x will multiply x, makes it x squared, and then this x will multiply negative 8, makes it negative 8x. Then now this 8 will multiply x, makes it positive 8x. And then this will multiply here, makes it negative 8 times 8 is 64, and positive 8 times negative 8 is negative 64. Now, if I collect the like terms here, positive 8x and negative 8x are like. And 8 take away 8 is 0. So 8x take away 8x is 0. And I get x squared take away 64. But hang on. What have I observed here? I observed here that my expansion resulted as a square of my first term take away the square of the second term. So this can now be used as a shortcut. So if I say x minus 3, x plus 3, which simply means that if you have an expression, if you've got two expressions multiplying together, binomials, where the terms look more or less the same, the difference is only the sign. Then you can simply use a shortcut, which is you pick up the first term here, square it, always put a minus, and pick up the second term, which is, and square it, which is 9. So x squared take away 9. Yes, Eklavya, what help do you need? Type it. So that's the shortcut. In algebra, we call this as DOPS. Difference of product squares. Difference of product squares. So what it tells me is that if I have two expressions which exactly look like this, which exactly look same, two binomials which exactly look same, the only difference is a positive and a negative here, and the terms look alike, then I can simply square them here with a difference. So a plus b, a minus b is a square minus b square. So that's called difference of product squares. Let's do a few questions. I'm going to page number 3. Okay. Give me the answer for, go for it. 6 minus x, 6 plus x. I'll answer your question, Darsh. What if the terms are different? If the terms are different, then this formula does not apply. Then you do your regular binomial distribution, multiplication using distributive law. It is only when the terms are same and the difference is the sign. That's about it. Good. Chat's overflown. Good, Ishita. Good, Veera. And thanks for being quiet, guys. I think there are a few who make noise every week and they don't listen at all. I thank all of you who are silently listening and not, spamming on the chat, right? For any exam, to crack any exam, the first trait that you need is respect your teachers and your parents. So if I'm asking you all not to make noise on the chat and you're not listening, probably you're failing on the first trait straight away. So I will urge you to keep quiet. I don't like students to be thrown out of my session. So please, admin, Arav, and Shadow the Hedgehog, you three need to be quiet, okay? Don't push me to, throw you out of this session. All right. Now, A plus B, A minus B. Now, it could be, guys, A minus B, A plus B. Doesn't really matter. Why? Because I told you 3 times 2 is same as 2 times 3. And it is nothing but A square minus B square. Here, my A is 6 and my B is X. So A square is 6 square and B square is X square, which makes it 36 minus X square. All right, next question. 3x plus 5, 3x minus 5. Go for it. No, Eklavya, it's not 25. So A plus B, A minus B. What is my A here? You see, A is 3x and B is 5. So A square minus B square. Now please, whenever you are squaring 3x square, if you're squaring this, square everything. So it's 3 square, x square makes it 9x square. So this is 9x square. Take away 25. Good job. Good on you. All right, let's move forward. I'm going to the next page now. Okay. Negative 4x minus 5, negative 4x plus 5. Go for it. Good. So your A is negative 4x and your B is 5. So when you square a negative 4x, A plus B, A minus B is A square minus B square. So it's 16x squared, take away 25. Now, I'm going to the next page. I want you to multiply two binomials, x plus 2, x plus 2. Go for it. Now, all right, a few of you are correct, a few of you are not. So let's do this. Now, be mindful when you're attempting this. It is the formula that I explained you earlier was DOPS, and DOPS tells me that A plus B, A minus B is A square minus B square. A few of you have applied DOPS here, which is not the case. Look closely what's happening here. If you look closely, the sign is not opposite. The sign is the same. So I cannot apply DOPS here. Let's go with the regular binomial expansion. So my x will multiply by x, makes it an x square. Then my x is multiplied by positive 2, makes it a positive 2x. And then this 2 gets multiplied here, makes it another positive 2x. And this 2 is multiplied by another 2, makes it a 4. If I, yes, PS, you can. So you can then add the like terms, which means 4x plus 4. That's the expansion. Now, let's look at this 4x separately. What is this 4x? Let's talk about this 4x. Can I write this 4x as 2 times 2 times x? Now, if you look the pattern very closely, this 2 is nothing but this 2, and this x is nothing but this x. So this is basically an expansion. So I can extend this to write it as 2 times 2 times x plus 4. Now, if I generalize this to another perfect square formula in algebra, and yes, Veera is right, this, so if I rewrite it here, x plus 2, x plus 2. Let's say my x is an a here, x is an a, and 2 is a b. So I have my a square plus 2 times, this is b and this is a. So I can write either a times b or b times a, doesn't really matter. And this 4 is a square of this number, plus b square. So I have now landed on another important formula in algebra called the perfect square formula, which says that a plus b times a plus b is a square plus 2 times ab plus b square. So now if I go to the next page, I summarize what I just talked about. So what I've said is a plus b and a plus b is a square plus 2ab plus b square. Now we also know, I think in session number 2 we talked about x times x means x square. So a plus b times a plus b can be written as a plus b square. So the formula is a plus b whole square, or a plus b is equals to a square plus 2ab plus b square. And this is called the perfect square formula. Now, let's do another question and apply this straight away. So, can you solve m plus 10 whole square using this formula? Good. I think most of you've got it. So if anyone who's not got it, I'll quickly do this again. I'll use this, and this is a is m and b is 10. So I will say a square m square plus 2ab, 2 times a, which is, sorry, not a, 2 times m, and b is 10 plus b square. So it is m square plus 20m plus 100. So that's the formula, and that's the answer. I have put one person back into the waiting room for not adhering to the decorum of this session. So if anyone now makes any more noise, will be put back into the waiting room. All right, we've got some children who are very serious about it and they're learning. So please maintain the decorum. P.S. It is not DOPS. So what we've learned is something called a perfect square formula, which tells us that a plus b whole square is a square plus 2ab plus b square. Yes, the previous one was DOPS, correct. Difference of product square. So we've learned 2, which is a plus b, a minus b is a square minus b square. All right. Now, a very similar formula, the perfect square formula is that we are going to do next is a minus b whole square. So we did the a plus b whole square. Yeah. Now we are going to do a minus b whole square, which is a square plus, shouldn't say plus here, maybe it's a square minus 2ab plus b square. Okay, I'll explain you here, Shaban. Don't worry, I'll explain you here, right, using this. Now, let's use this formula. So now, if I say I have y minus 3 whole square. So what are we doing here now? I'll do it now rather than you doing it. When you've got this, you are applying the perfect square formula a minus b whole square. Your a is y and your b is 3. Don't ever do the mistake of taking this b to be a negative 3. Never. Let this negative sit where it is sitting. Don't touch it. A is y. The first term is a. The second term is b. That's about it. Now, whosoever has not understood the first one here, it is very similar to the one that I'm doing. So if you understand this, the positive one will be simple. So a square is y. I say y square. Minus 2. This 2 will always be there. B is, now a is again y and b is 3. Don't do the mistake. I'm telling you again and again, don't take this negative along with b. B is positive 3 plus b square. So now you just expand it. This becomes y square minus 6y plus 9. Is this clear to everyone now? How we're doing this? Eklavya, is it clear to you now? No, no kind of. Let's try one and we'll see where you land. Now I'm writing the 3 formulas right on top here. Yes, you can, Darsh, you can expand it using the distributive law of multiplication, but that will be so lengthy. There is no reason doing it, right? You will waste your time, right? That is why these formulas are there, to give you shortcuts, right? So a plus b whole square, a minus b whole square, and a plus b, a minus b. So now you've got, this is a square plus 2ab plus b square. That is a square minus 2ab plus b square. And this is a square minus b square. These formulas are the lifelines of algebra, especially for the exam that you are preparing for, and even until grade 9 and 10. This is even required in grade 11 and 12. So these 3 formulas are the lifelines of algebra, and that is why we are spending so much time here. Now, I will give you a question which will make use of one of the 3 formulas here, and we'll see how you land. Okay. 7x minus 4, 7x plus 4. Go for it. Next term, DJ, we will jump on to linear equations, but we need to understand this, please. Go for it. Anyone making noise will be put back into the waiting room for quite some time and will not be admitted back. Eklavya, are you clear with this? Which formula you're using? You're using DOPS here, the third formula. Good job. Good job, my dear boy. Keep moving. Good, Ishita, Veera, Rishan. Good. All of you. Great. Arman. Okay, Karan, we'll do it. I'll do it. Don't worry. Formula number one, formula number two, formula number three. Whenever you are given something like this, first step is you need to identify which formula is being applied here. It looks similar to which formula? Okay, doesn't look like one, doesn't look like two. All right, looks like three. A plus B, A minus B. A is 7x, B is 4. A square, A is 7x, 7x square. Take away B is 4, 4 square. So this becomes, so Karan, this becomes 49x squared, take away 16. A lot of you were left, right? Good job. If anyone's keeping track of time, feel free to, leave the session, right? All right, cool. Next one. Now, be careful. Be careful what I'm giving it to you now. Go for it. Take your time. Don't rush it. Identify which formula needs to be picked up, and then no rush. Apply that formula, and we see where you land. This will tickle your brain. It is, Navya. It is confusing, I know. And fractions is always a challenge, I tell you. We'll do it, don't worry. We'll do it. Okay, as you're solving it, and in the interest of time, let's do it. First of all, it is very important to see which formula I'm going to apply. I've got a whole square here, so that means either formula number one or formula number two. But I've got a positive here, which means I'm going to use formula number one here. Yep, I think most of you are right here. So, I mean, anyone who hasn't got it, be with me. So A is 2 over x and B is 4x. Let's apply this formula. A square 2 over x square plus 2ab. 2 times A is 2 on x plus B is 4x plus B square, which is 4x whole square. Now, let's expand it. 2 over x square means the square of the numerator over the square of the denominator. And here, you just need to sort of solve it a bit more algebra here. What we were doing in the last two sessions. Now, x can cancel x here. And you're left with 2 times 2 times 4, which is 16 only. What most of you have done here is, and I didn't see this, what you've written is you've written 16x over x. But who is going to solve this? Xx has to be cancelled. I told you this is grade 9. I change the color back to blue. All right. Plus, come on, purple. Yeah. Plus 4x whole square, which is 16x square. That is the answer. I know, Sakita, this is confusing. So I repeat again, no, there's nothing on the denominator here, PS. So if I look here, you have 2 times 4x over x. So what's in the denominator here? You've got 2 over 1 and 1. So denominators are all 1 times x. So that is why denominator is x. And you've got 16x on the top. And that is why you've got xx cancel. All right. Is this clear? Let's do one more. I loved it when you get confused. All right. Let's do one more. I'll write the formulas again just in case you don't have to change the pages. A plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. And a plus b, a minus b is a square minus b square. Now, let's do another one. Another tricky one. 5x square minus 2y whole square. Identify which formula you need to apply and then solve it. Go for it. Go for it. No, Veera. No, Shadow the Hedgehog. Incorrect answer. Have a closer look. Have a closer look. Identify the formula first. There is no rush to the finish line at this point. I'll quickly jump on. Now, as you solve it, I will use formula number 2 here. My A is 5x square and my B is 2y. Let's do it. A square 5x square whole square minus 2 times a b plus b square. This makes it 25x raised to the power of 4 minus 5 times 2 is 10, 10 times 2 is 20x square y plus 4y square. A lot of you were incorrect here. When it becomes a lot of powers, it becomes confusing. Good. Good, Navya. Good, Sakita. Rishan. Good. Good, good. Sorry, I'm not able to respond to all of you, but yeah, I think you're doing the right job here. All right. Another tricky question. You wanted hard, right? Someone really wanted tricks here, right? Let's deal with this. Can you solve this, please? Go for it. Identify the formula first. Can you tell me which formula is going to be applied? Type 1, 2, or 3. Which formula is going to be applied here? Yep, Ishita, that was the right answer. Good. Correct. Go for it. Apply formula number 2 and give me the answer. All right, let's quickly do that. All right. What are we going to do here is BODMAS comes into play first. I will solve this first. So x minus y, I'm keeping 2 outside. X minus y becomes, whole square becomes x square minus 2xy plus y square. I have used, no, no, no. A few of you are throwing incorrect answers. Few of you are correct. But now just hold on. Hear me out. Okay. Look here. I will not touch this 2 at all till the time I have expanded using the perfect squares. Karan, be with me. Once I've done that, it is very simple expansion that you've been doing so far was your monomial versus trinomial. So this 2 gets multiplied here, becomes 2x square. Then 2 gets here, which is negative 4xy. And then this 2 gets here, which is 2y square. That is the answer. 2x square minus 4xy plus 2y square. All right, cool. I hope this is making sense now, right? Now, no 8xy. You've got a 2 here and a 2 here, which just makes it 4xy. All right, I'm going to the next page now. We've got 5 more minutes, and then after 5 minutes, I will unmute. I will unmute you all. Now, one of you has used an inappropriate word in the chat, and that's been reported. Probably I will not allow you to enter next week. Right. All right. Now, x minus 3 whole square. Solve this and also solve this. 3 minus x whole square. Let's see what answers do you get. All right, the formulas are a minus b. That's the formula that you're going to use. A minus b whole square equals to a square minus 2ab plus b square. That's the formula that you need to use. Are you seeing any difference in the result is what I am interested in knowing. Another person has been pushed back into the waiting room for not maintaining the decorum. If you're not maintaining decorum, you sit in the waiting room, please. All right, let's solve it. I'm marking this as red, and let's solve this. Let's see if there is really a difference. A is x and B is 3. Let's apply it. So this becomes a square, which is x square minus 2 times x times 3 plus b square, which is 3 square. So the answer is x square minus 6x plus 9. That's the first answer here, the one that's marked in red. Is this clear to everyone, what I've just done here? Quickly say yes or no. And I'll do the second one now. Eklavya, it was straightforward, my dear boy. So a square, a is x and b is 3. That's about it. And I'm just applying this formula here. A square, x square, minus 2ab, 2 times x times 3, plus b square is 3 square, which is 9. Now, let's do this one and try doing that. Now, in here, a is 3 and b is x. Let's try that. A square, which is 3 square, plus minus 2 times a, which is 3, and b is x, plus b square, which is x square. So the answer is 9 minus 6x plus x square. Now, can you tell me, looking at these two, is there any difference? Is there any difference? There is no difference. Just exactly kinetic, they just swapped sides. That's it. Right? They just swapped sides. So, in the world of formula number 2, it does not really matter whether I write b minus a whole square or I write a minus b whole square. The answer will always be a square minus 2ab plus b square. So that is what I wanted to, bring to your notice, which at times we miss. I've pulled the students back from the waiting room into the main chat room. But, if anyone is not maintaining decorum, using inappropriate words, will be pushed out and will not be allowed to admit inside. Right? Today was just a very small example. We need to maintain decorum here. All right. Next time, once you're sitting in the waiting room, you'll not be allowed to get in. All good, cool. So that brings down to the end of this session and logically to a point where we can start building our algebra skills from here on. So you've been exposed to the 3 key formulas here, and this is required throughout your journey. All right, cool. As I promised, I will now just stop sharing the whiteboard, or probably let the whiteboard sit as is. And I will just allow you to unmute yourself, or maybe if you want to quickly, have a chat about the sessions. We've got a few minutes, but raise your hands, and probably I will unmute yourself. I will unmute you. If you've got any questions, queries, concerns, anything that you want to chat about, you can raise your hand, and I can unmute you. All right, let's unmute people from top to bottom, right? Be short and sweet, please. Okay. Yes,
Oh,
PS.
are we doing inequalities?
Yes, we will do inequalities, but inequalities are further down, right? So
Oh, okay.
till the time we don't know how to solve linear equations, we cannot solve inequalities. But
Okay.
we certainly will do it.
So are we
Yeah,
doing inequalities with linear equations, or are we doing
we'll do.
inequalities after?
It's in the plan. It's in the plan. Term 4.
Okay,
Right. Cool.
thanks.
Mute yourself. Tarun,
So what will we learn in our term 4 classes?
term 4 classes will start from where we left. So we are going to introduce worded problems, converting expressions, converting worded problems into expressions, and then we'll start doing linear equations, solving worded linear, problems, inequalities. Yeah, there's a lot to do. Yeah,
Okay, thank you.
thank you. Please mute yourself. Vera,
My question is that during the linear equations thing, will we like still use the same formulas and other things?
absolutely. I mean, at least your expansions, your binomial expansions, monomial to binomial, the distributive law that we use today will be used in linear expansion quite heavily.
Will
And that is
associative and commutative law also be in
everything,
use?
everything, everything. All the laws, whatever we have learned so far, everything will be used
Not
in
a
linear
problem.
equations.
Thanks. Thank you.
Thank you very much. Avi, Avi, sorry.
Yes, sir. I don't have a question, but I'd just like to say thank you because your simple way of teaching and maintain discipline helped me grow as a student.
Thank you very much. I loved it. Yeah. And thanks for being patient, and your learning, your attitude of learning is great. Yeah, thank you. All right, Siva, anything from your side?
Sir, what will we do over the term break? Will we have any homework?
I will keep sending quizzes every week
Okay,
during
sir.
term break. Don't worry, I'll not leave you guys like that.
Okay.
Cool. Kinetic.
Will the questions get any harder from now on? Like even
all
harder?
the all the quiz part that I am sending, they're all harder questions. So here there are a lot of other students who are of different, at a different level. So I can't throw very hard here. So the
Oh,
harder questions will be a part of the online quiz that I sent.
oh
All
yeah,
right.
thank you.
Cool. Thank you. Yes, Shadow the Hedgehog.
When will we start trigonometry?
It will be further down. Once we conquer algebra, trigonometry will be the next.
All right, thanks.
Thank you. Kinetic. Last hand.
I have.
Yep, go for it. Sanvita. No. Mute. PS.
So will we also learn like this in these courses, or
Yes, we do.
okay,
Further down. Further
thanks.
down. Maybe term 1 next year.
Okay, yeah, thanks.
All right. Sanvita, I'm trying to unmute you. Not sure. Yeah, go for it. You can unmute yourself now. Can't hear you. Sorry. All right, cool. That's pretty much about it from my end today and for this term. Thank you very much for being patient, and I will keep sending you more during the term break. It is a term break. Don't break the term, right? You know what I mean, right? So do studies on a daily basis. At least maths and English require you to brush up on a daily basis. Oh, good. With that in mind, thank you very much. 4 minutes passed. It was good having you for the whole term 3. I mean, we had half of it, but yes, term 4 will be full on and we'll do a lot more deep dive. Thank you very much, everyone, and thanks for again attending this Sunday morning meditation. Thank you.